Hello and welcome to my channel. As I mentioned more than a year ago on the Road to Swift 6 video, concurrency was a big theme for the language. Swift concurrency now is the major focus of Swift right now, and it's a big topic that it's broken down into so many different proposals that it's kind of hard to get a whole picture. But on this video, I want to take a first look at what's coming in Swift related to concurrency. We're going to take a look at async await and talk a little bit about what it means and how it's going to change the way we work. If you've seen my videos before, you know that I'm not just going to give you a quick tutorial to know how to use async await, but I'm going to try to walk between simple examples so you understand what I'm talking about, but also diving deep into some specific topics because that's what I like. I want to geek out about these things because it's what I love. And I want you to have these nuggets of knowledge so you can go and explore on your own this big topic, because I remember it's such a big theme, this Swift concurrency, which also means we're not going to go deep in everything. If there is more interest in this kind of video, I have some ideas into talk about how it's broken down and how everything relates to each other, because it's kind of complex and it took me a while to actually put all that information in my head. So I think it's going to be useful for everybody to have this idea. But again, this is not that video. In this video, we're going to start by looking at the most obvious thing, which is async await. So to start, let's take a look at async await, which is one of the most visible things, the first thing that catches everybody's attention. So I have here some code ready where we're just importing foundation, and then I have this deferred statement that just keeps a run loop going. I'm using dispatch for this. That's because we're going to be doing some asynchronous code, and because this is a command line application, we need for somebody to wait on the asynchronous code to change. Just as a reminder, all of this it's still in progress. A lot of these things are not even completely approved. Things may change along the way. So by the time this reaches official release, I'm pretty sure some of the things are going to be different. But I hope that the overall ideas stay the same, so you can learn with me a little bit today. I just start always with a print hello, because it's very useful to know if Xcode is actually doing what you expect. So to start with, let's take a look at what these new keywords mean. So we have an async keyword and an await keyword. So these are the two new keywords introduced. You may recognize them from many other languages like JavaScript, C#, like Kotlin. A lot of these languages have these nowadays. It started introduced like years ago in many languages, so I'm very happy that Swift has them now. So to start using them, we need to write a function which it's just going to be an example function, not anything fancy. So as you can see, we have these two functions here that are just doing very simple things, just printing, calling another function, printing again. And here we have just a slip to show a little bit how this works. So what is new now? So as you know, this is like normal programming. So these functions, they just start executing sequentially, and when they reach another function, you call into other function, and then when this is done, it just comes back. So what is new? What is new is that now you can decorate functions with this async keyword, and we can do it in both. So now this tells the language that this is a different kind of function. Now we have basically two different walls, synchronous functions and asynchronous functions. Now, as you can see, the comparison is already telling us that we can call an async function without marking it as an await. So we will need to await for this function to complete before proceeding with our code. So on the surface, that's basically what has been added, the async keyword and the await keyword. What this gives to the language, it's kind of an implementation of coroutines, which allow functions to suspend themselves and to resume back later. Up until now, if you had a normal function, you started the function, you could call as many things as you want, but at the end of the day, everything came back synchronously and you finished the function. And that was it. There was no more interaction. Now, with this new world of coroutines and async and await, you can actually have a function that starts and just pauses execution. And then later down the line, when everything has finished that it has called, it will automatically resume the execution. So that's basically what it's coming. What is very important for me, and it's one of these nuggets of knowledge, is that This is not just syntax sugar for things that we may be used to, like promises or futures and stuff like that. This is not like it's uh, just sugar for a library implementation of promises and things like that, like which, for example, other languages, that's how it works. Everything is implemented in kind of like promises and features, and then they just add async await as sugar for that. This is not how it works in Swift. In Swift, async and await are an integral part of the language and the semantics of the language. So as I was saying, these functions now belong to a completely different world, the world of async functions. They can operate with synchronous functions, with the functions that we had all along, but they belong into a different world. And that's very important because it unlocks the potential for promises and stuff like that to be developed at a higher level, at the library level, for example. So that's not what is part of the language. What the language is allowing us is to suspend functions and resume them back later. And that's it, which is a very small thing that is the building block for everything else. Now let's try to run this code, and to run it, we basically just need to call our function, but as you can see, the compiler is already gonna telling us that we cannot call async from a context which is not supporting asynchronous functions. So even if we do an await, we're at the top level here, and basically this is not supported because you need to be in the async world to call async functions. That's what I meant by they are kind of different worlds. In practice, I doubt this is much of an inconvenience because when you're working in applications like you're already using other frameworks, so you're all gonna be already in the context of those frameworks doing your work, and asynchronicity is gonna be part of that new world. But now, because we are in a simple command line tool, everything is not fully ready yet, we need to massage a little bit the code to make it run. So I just have here a normal function. Note that this is a normal function, a synchronous function, and we just call it as usual, but we annotate it with this async handler. Don't want to go too much deep on it, but basically think of it as like this is creating behind the scenes all this asynchronous world, and we can opt into that just by calling it. So this is gonna manage all the async tasks for us. And again, remember, because I have this here, the command line tool is gonna wait for it, and we are not gonna end the program too soon for this code not to run. So if we run this, you're gonna see how we're going to sleep for a couple of seconds and then back for a sleep and go. So this is just running as you expect. It's just that now this function is suspending here potentially and coming back. But one of the interesting things that I want you to notice here is that there is not real concurrency here. So that's one of the important aspects to understand about this, which I think it's one of the biggest things that has caused more confusion to understand all this feature, because the feature, like the whole topic, it's Swift concurrency, but then the first thing that it's added into the language, it's async await. And async await per se is what I just said. It's just a coroutine implementation. It's just allowing us to suspend functions and resume them back later. That has nothing to do with concurrency. And that's what I think it's confusing a lot of people. Because when you look at this code, there is no concurrency here. If I try to run if I want to, for example, run this thing twice, there is no magic here that's gonna make this parallel or concurrent or anything. And of course, this is a very simple example because we're just in a command line tool, so everything runs synchronously. There is nothing, no background processor running or anything. But even if that was the case, it will not run concurrently with anything else on the same thread or whatever you want to call it, or in the same queue, doesn't matter. There is no concurrency here. This is just the language allowing you to suspend execution here and resume it back later. And that's it. So you may think, how useful is that? It's the building block for building everything else. So now let's explore how concurrency is introduced thanks to this building block. The first thing I want you to realize is that even if you see kind of these things, and a lot of the things you're gonna see now is like a little boilerplatey, it's all because we need to integrate with existing synchronous systems that use completion callbacks and stuff like that. In reality, I expect that you are just gonna be awaiting on things and maybe making your things synchronous that are gonna call to other asynchronous functions, because I expect that many of the things that we use are already gonna be async or with time, they are going to be all converted into this new Swift concurrency paradigm. So, for example, I want to show you now how the majority of the APIs that we're used to use on the Apple SDKs, they are going to be automatically converted to this async wall thanks to the typical Swift Objective-C compatibility that we are so used to. So what I want to show you here, it's basically a diff on the SDK layer that is exposed to Swift. And again, this is just an example PR, like this is not still gonna be fully available or anything like that, but I want you to see how the compiler is automatically converting many of the things. Let's see if we find something that, for example, if you are using HomeKit, you're used to do an add action, and then you have a completion handler that is the typical completion handler that we use nowadays everywhere, okay? But then now you have also available this add action that doesn't have a completion handler. You can see how the completion, this is not here, this parameter disappeared, and instead we have this async keyword here, which means that this is an async function. So as you can see, for everything that comes from Apple SDKs, for example, which is a lot of things that we use every day on iOS and Mac programming, you're going to have many things, pretty much the entire majority, unless it's an obscure API that doesn't follow exactly the norm. You're going to have everything automatically converted, which is very nice. The point here is that many of the Apple things are going to be automatically done, and I expect that third-party frameworks are going to do the same pretty quickly. So don't expect that you will have to write a lot of wrapping APIs. But of course, if you have your own code that you want to convert to Disney World, and why you shouldn't, there is a way to do that. And now it's what I want to show you. So let me remove this code from here and instead use a callback API that I have ready. So this is inspired and is using some data source from my Runeterra code that I have because you know I like it very much. And this is basically just a synchronous function, which you can see the definition here with a completion callback, which gives you an array of cards. And then we print here how many cards we have. We pick the freeze card, and a card has assets, which are basically image of the card itself and the artwork in full screen. So then for the game absolute path, which is the card image, we want to fetch it from the network, and we get an image result back, which is basically just a result where we have the data, or an error if it's a failure. And then once we have that, we just print the count. I'm not going to make anything fancy to show it because that's not the point here. But then we fetch the full screen image, which is the fancy art from Runeterra that I love very much. And again, it's the same thing. It's the same method call. It's everything the same. When we have here, we print the art asset, and that's it. So if we run this, we see how it's just going to run. It's going to fetch 176 cards, the first image, the art image, and that's it, okay? So that's pretty much what this API does. I tried to make an API that shows some of the normal use cases. So first of all, we have an API that just completes with data. There is no error here. There is no possible error. If for some reason something fails, we're just going to get an empty array, and that's it. Then we have another API method here, which the completion callback has a result. So it can fail and it can succeed. This means that we need to handle it here on this case, and then if we fetch again, we need to handle it again, and you see how we are chaining and nesting the API callbacks, and that's not very nice. That's why many people switches to like promises and features, or for example, many people switches into a full FRP with RX, and that's a huge new wall that you just have to learn just to deal pretty much with this. Because I really think that when you have something like this on the language, when you have async await, that reduces a lot of the use cases to having the whole FRP world in your code base. Honestly, I think that on the past few years, the iOS community and also the Android community has switched a lot into this FRP mindset, which is very huge and very nice because it solves a lot of problems. But it's also something that I will argue 90% of the time you don't really need. If you look at other communities that are always ahead of us, honestly, they already for years have been using unidirectional frameworks. And in that aspect, when you're building UI applications and you have a unidirectional flow, the necessity of using FRP frameworks it's kind of reduced. You still need some way of dealing with asynchrony and concurrency and that kind of stuff, but you don't need to learn this whole huge package of things that have so many operations and many difficult things to handle because you need to manage the memory and stuff like that. It's not useful for the vast majority of cases, and that will surprise many people, I know. But the reality is that FRP was designed to deal with sequences of data through time. And the vast majority of things that we do is just a one-off, give me data from the API and give it back. And yes, we want nice ways of massaging the data with maps and reduces and whatever you want, but you don't need the whole FRP framework for that. And I think that once we have this async await here, you're going to see now that you don't need all of that complexity. You just need something like this, because for one value over time, you just need async await. At least that's what I'm thinking right now. Maybe I change my mind later, but I'm pretty sure we're going to see a lot of less usage of FRP frameworks, or at least they're going to be hidden so deep that we're not going to see it on our day-to-day. But let me show you how all this mess, it's converted into a nice async await code just by wrapping it a little bit with things that you are already used to. So let me show you this code that I have, that it's basically creating new functions, asynchronous functions, that wrap our existing code. As I said, ideally, when we start doing these things, if we can't, the code that we are using to do all our existing basically implementations, they are gonna be using APIs that are available with async await. So we should just switch that part of the code instead of wrapping in another layer. But just in case you still need to support all things, that's very nice that we have this available. So how we do this? Again, we need to import underscore concurrency now because this is not public yet. You need to enable it with a compiler flag. So you can ignore this for now. Eventually, it's going to just be part of the language and the standard library and all that stuff, so you don't have to worry about that. But let's get to the point. How do we convert a completion callback-based API into an async function? We need to use these things called continuations, which is a way that we have to interact with the suspension machinery. So here, this await keyword, it's going to make this point here suspend the function, and then we get inside this callback, we get this object, which is a continuation. And as you can see, this object has a very common API interface that you are used to if you have been using, again, Rx or any promises API. This is kind of the API that you get there when you want to wrap existing code to transform it into that world. So that's a very similar scenario here, where we have a continuation, we call our completion callback API, and when we are ready, we call resume, returning the correct value, like in this case, or in this case, we pass the result, which is a very nice API, to be honest. Like, there is another API here, which you can pass the throwing error or returning the data. But if your callback-based API already uses result, which nowadays it should, you can just pass the result and it does the checks internally for you, which is very, very nice. So that's how you convert callback-based APIs into an async await world. The point to note here is this unsafe word. This is an unsafe operation because async await, again, is just making a normal call, but that can be suspended and resumed later. And when the function completes and you get a return value, it's just gonna continue with the rest of the sequence of the code. So there is no way for that to give you multiple values. And that's very important because when you are writing yourself this continuation code to map from a callback API to an async world, you need to be very careful to not call it more than once or to not call it ever. In other words, you must ensure that you only call the resume once. And because there is no way for the compiler to ensure that, it's basically why it's called unsafe continuation. If I make the mistake of calling it twice, it's kind of, I'm not sure if it's undefined behavior or what exactly is going to be the end result, but you can see that, for example, now I get a crash. Maybe that's because I'm just running in debug mode or release mode. The point is that the system and Swift doesn't do anything for you. It's up to you to make sure you don't do this. If you do, it's not the language problem, it's your problem to make sure you solve it. So, of course, you shouldn't do that. But the reality is that we work with code that we don't have full control over, so we are not 100% sure of what it's doing. or even our own code, it's old or it's too complex to reason about, and there should be a way for us to safely assume that this is working. So there is another API here that it's called a checked continuation. You can see that the continuation API is exactly the same. I don't have to change any code, so you can switch between one and the other very easily. And the only difference is that this, it's checking some things at runtime. Again, the compiler cannot ensure that we do things properly, but you can see now how at runtime, it's detecting that I'm calling this twice, and I see a proper error, telling me exactly that I'm misusing the continuation. So I try to resume it more than once, which is not allowed. In the same way, if I never resume the continuation and just leave it handling, this checked continuation API, it's just gonna be checking for that, and it's gonna show a log, a warning in the console. In this case, it's not gonna trap the program. So again, you probably want to do this when you are migrating code, but eventually it's very nice that we have the unsafe part, because even if the word scares a little bit and it's called it unsafe, it's like, yeah, I don't want to use it, but really you should be using it. There is some performance cost on doing these checks at runtime. And if you know that, like, for example, on this case, I'm just writing this code right now. You see here, there is no complexity here. I know that it's going to be called once because I just wrote these fetch cards. I have full control over it. I know what I'm doing. So I don't have to lose performance at runtime, and just I can do what I know exactly and tell the compiler to trust me. As you can see, this API is very nice. It supports code that doesn't error. It supports codes with error. Very nice API. So that's everything you need to do to wrap your code. And if you want to see how it changes, you remember that we have this code here, which all this mess of code, checking errors and callbacks, all the stuff that you already know that it's a mess. I don't have to convince you of that. And now you can see how here we just have nice, kind of like synchronous code. That's what you are used to write all day. You just fetch something, you use your normal methods, you fetch again, and stuff like that. And you just need to sparkle a little bit with this await keyword here and there. And now all this thing that looks sequential and synchronous, it's actually being suspended, and it automatically waits for the completion, and it just mixes an asynchronous world, a concurrent world, with sequential code that it's easy to read and understand. You may remember how when we get error handling in Swift with do, throw, catch, and all this stuff, basically everybody was like, okay, yes, but my whole code base, it's full of asynchronous callbacks and stuff like that, and this doesn't work with callbacks, because if you throw from a callback, the calling side doesn't know anything about that. So the error handling in Swift was not very thought properly for asynchronous things. And that was known and accepted because we knew that eventually we're going to have a solution that mix both things together. Well, this is the solution, because the thing that you're looking here is just sequential. You actually now have a system where when this fetch fails asynchronously, when it throws an error asynchronously through the callback that we wrap and everything, eventually that error is going to be bubbled up into this context, and now you can use normal error handling with try and catch and have the error here handled in one place from both callbacks. It's just the thing that you are used to do, which is very nice. You don't have to learn a whole new world of APIs and stuff just to deal with this. So that's huge. So that's how to map between the existing callback APIs into this asynchronous world, and you can see how fancy it is. I just want to mention another thing that's very important, because so here there is sequential code that you can read, but as we said, it's suspending, and it's actually using concurrency. This code is also using proper concurrency, not because the async await is doing anything fancy, but because behind the scenes I'm using dispatch and all that stuff on my normal code, on my callback API code. I'm using dispatch queues and global queues and all that stuff. So this is what is allowing me to run things concurrently and stuff like that. And that code will allow other queues to run in a concurrent way. That's what's giving concurrency to this code, not the async await. The async await, again, is just suspending things. I know I'm repeating myself a lot, but there are these key ideas that I want you to get from this video. But you will say, why am I waiting for this image first and then I'm fetching this image when there is no relationship between them? I could just fetch both in parallel and that's it. And that's not what's happening, okay? This await, it's literally suspending the execution here. And until this fetch doesn't finish and we get the image data, you are not going to continue the execution. You can see here how first we printed one image, and if you saw when it runs, it actually takes seconds between one and the other. You see? If this was in parallel, you will then see this waiting here. So that's where this Swift proposal about structured concurrency comes into place. And that's a whole huge topic that I probably want to address at some point because I find very interesting, but it's in contrast to promises and features and all that world. It basically makes everything much more easier to understand, and I'm pretty sure that you understand what I mean. Like, yes, when you are dealing with promises and features, you get rid of a lot of complexity here in terms of visual noise. There is a lot of noise here on this code that you get rid of all this nesting, all this error handling, all of that disappears thanks to promises and features. That's totally true. But there is something that makes understanding that code also not as nice as it could be. And it's basically, long story short, it's that you have one object that represents your asynchronous operation, and that object can be handled by anybody because you can pass it around. That object maybe it doesn't never finish because nobody listens to it or something like that. So it has many things that make things harder to understand. Structured concurrency, on the other hand, and I don't want to go super deep on it, basically makes all the asynchronicity look from what we are used to. We're used to reading code here that we know what it does because we know that it goes from top to bottom. There may be loops and there may be ifs, but we know for sure that at the end of the day we're going to end up at the end of the function. This scope is going to finish, we're going to end here, even if in the middle a lot of things happen. When you're dealing with promises, you throw that out of the window because your code is going inside the promise and you never know when that's going to finish, and it's a mess. Structured concurrency solves that because structured concurrency makes sure that the execution is always in the scope of your function. So yes, we're calling here something that is asynchronous and it may call many things and do whatever it wants, but at the end of the day it's gonna roll back into our scope and we're waiting for that and we get the data and we continue to the next one, and we're gonna be doing that until the end of the function. And we know that when we are ended here, all the synchronicity here has ended. So there is no possibility to throw something and just let it go and we don't have control over it. That's what the structured concurrency overall says. I know it's not a great explanation for now, but what I want to show you is that thanks to that and thanks to the design of this Swift concurrency system, we actually can run things in parallel with a very nice syntax because structured concurrency allows us for that. So the only thing we need to do, and that's super cool in my opinion, is that instead of doing a normal let, where we say, I want a variable here that it's going to hold something that it's on the right. And this something on the right, we now know that we need to wait for it to receive it. So instead of doing this, we just need to switch that to make the defining of the variable kind of asynchronous. And let me show you what I mean. So the only thing we need to do is remove the await from here. So we are no longer awaiting into this to finish. And you will say, wait, but how is this working? If this is asynchronous, we need to wait for it. It's like, what we're doing instead is we're declaring a variable, a let variable, that it's asynchronous. So the binding of this variable into the result of this operation, it's asynchronous. So now we have here a variable, a let binding that it's asynchronous. So when this is happening here, this code, we're not waiting here. We're literally going image data, we continue and we go to art data. So both things are running one after the other, but they happen all together. You don't have to wait one to start the next line. And then at some point, you want to use this. At some point, you want to use this image data and this art data to do something. In this case, I'm basically putting them in an array and mapping and getting the count of bytes and adding them. So I know the total size of the images. Basically, it's just an example. But the point here is that when you want to use these two asynchronous let values, it's when you need to wait for them. So you can run all this stuff, and then at some point when you want to use it, you just need to wait for these two things to resolve. And the structured concurrency and Swift concurrency, it's gonna understand that there is a dependency here between these two values here. There is a dependency with these fetches here that they are asynchronous. So it's going to know to wait for both. And when both complete, you are going to continue with this code. It's going to create the array, and then it's going to compact map and all that stuff. You can see how powerful this is. Like, we not only get a much cleaner and nicer code than this, which is the original, but you also can get concurrency and running things in parallel for kind of free. We just need to change a little bit the structure of the code by moving the await to the async let, and that's it. And all this mess here doesn't even deal with that. Like, you can imagine how we will run things in parallel here, with keeping variables and completion handlers and stuff like that. Like, it's totally doable, but you don't want to read that, And here it's just like the normal code we're used to, just with a couple of keywords more. So I think this idea is very powerful. Again, structured concurrency is a huge topic that makes things very nice, It's not a silver bullet for everything, because of course at sometimes you want to run things in the background and you don't care about how, when, or if it completes. And that's fine. That's also supported. There are APIs to do that. But the normal flow that you want is that when you start something at the top, you finish it at the end, and everything that happens in the middle, it's not going to change that. So that's what the structured concurrency is, which is something that we have with normal programming from years. For years we have used to do these things. Now this is giving us the power to have it also for asynchronous code. So that's it. That's the resulting code. That's what's coming to Swift with async, with await, with all this continuation, with all the Swift concurrency. And as I said in the beginning, the topic is much, much bigger. There is many different proposals, all complementing each other and depending on each other. And there is a whole world of things that are going to come to Swift, which on the surface I'm very happy, because even if the proposals are complex, I don't want to scare anybody, because on the surface things are going to be as simple as this: await, async lets, and that's it. Error handling is like we're used to, and all that stuff. Then we're going to have things like actors, which is a very nice way of dealing with concurrency, kind of like at a higher, different architectural level. It's very nice. And that's kind of what I wanted to show you today. I long the video, it's maybe a little bit longer. It's not a specific focus tutorial, but I hope that I give you kind of like some nuggets of knowledge for you that are going to help you understand this when it comes more on the public eye, because I'm expecting that in the next few months, if this is starting to coming into the next few Swift releases, you're going to see hundreds of posts. This is going to be the new norm. Everybody is going to be talking about it. So I hope that you got a glimpse of what's coming, you got a little hyped for it, and you get a little more knowledge now than what you had before. If there is interest about this, please show it with a like and subscribe, and I probably will make more videos talking about the overall concurrency theme. Again, not tutorials, but talking about the logic behind it and what's coming to Swift. That's it for today. Thank you all for watching, and see you next time.